Bismillahirrahmanirrahim. So, the topic which I have to present is the determination of hydraulic performance over the semicircular oblique crested weir. My group members are Mohammed Sohail, Jameel, Mohammed Alim, and Mohammed Muazzam Sattar. The presentation contents are
Sohail,
the.
your presentation, we could not see your presentation, your slides.
Sir, is it available now?
Not yet.
Sir, available it?
We could not see yet. Yeah.
Now it is
Now it,
visible.
now it's
Okay, sir.
okay. Okay. Yeah.
Thank you, sir. Thank you, sir. The topic which is I have to present is the determination of hydraulic performance over the semicircular oblique crested weir. My group members are Mohammed Sohail, Jameel, Mohammed Alim, and Mozam Sattar. The contents are the abstract introduction, research significance, methodology, and results and discussion and conclusion. The abstract of the paper is to study the effect of change in the geometrical features on the coefficient of discharge for circular crested weir in oblique plane. We have two types of weirs, one at 30-degree inclination and the second one 60-degree inclination with different type of crest height, one of 22.5 centimeter, 20, 17.5 and 15 centimeter. With the radius of crest is 12 centimeter, 10, 8 and 6 centimeter respectively. The results of the experiments was that as the radius of the crest increases, so the discharge coefficient decreases. Also, it was noted that as the crest height increases, so the coefficient of discharge decreases. While with the inclination of the channel, inclination of the weir increases, so the coefficient discharge also increases. These are the keywords. So these are the, it is the introduction. For as for many centuries, engineers have trying to build a structure across a river to provide required for proper delivery of the water. So different type of weirs available, like broad crested, sharp crested, and circle crested weirs also available. Ogive crest type weir. So the main point which I have to raise is that
Ibrahim, your mic is muted.
is it on now?
Sohail.
Yes, it is
Yeah.
fine.
Is it available?
Not yet. Sohail. Sohail Jameel.
Methodology of the experiment.
Your presentation is not visible.
Sir, is it available now?
Presentation is visible.
Sir, visible it is.
Okay. But I could not see. Okay. Then you can.
Okay. So
Yeah.
the methodology consists of the laboratory channel, which has been present there at UT Texla. It's the dimension of the channel is the 0.96 meter. It is wide, 0.75 meter is deep, and 20 meter it is long. The test section, which is where the test has have been performed, is there and is 5 meter at the downstream of the channel. So these are the dimensions of the weirs which have been used in the experiments. The 40 we have two groups of the weirs, one of 30-degree angle and the second one for 40-degree angle, and every weir have been run for 5 times, so 40 times 40 have been the experimental models. The for the discharge calculation, we have to use a weir, which is the compound rectangular trapezoidal sharp crested weir, which have been present there at the downstream. This is the formula used for the calculation of discharge. So this is the formula which has been used for the discharge coefficient of the circular crested weir. These are the results and discussion. So the first graph it presents us between the relations upstream head and the major discharge. As the head of the crest increases, so the discharge also increases. So the second one is the relationship between the head to crest ratio and the coefficient of discharge. It also presented that as the crest height increases, or the ratio between the height and the crest height increases, so the coefficient of discharge increases. But the point which is to be noted that as the crest height from 22.5 it continue to 15 centimeter, the coefficient of discharge overall decreases. So it means that the crest height affect the coefficient of discharge. The third one is the effect of crest height on the coefficient of discharge. So as the crest height increases, so it have the coefficient of discharge reduces. It has the inverse relation between these two. The fourth one is the effect of radius of crest on the coefficient of discharge. This figure shows that as the coefficient of discharge increases as the head to crest ratio increases, but with the increase only in the increase of radius of the crest, the coefficient of discharge decreases. The fifth one is the relationship between the inclination of the weir and the coefficient of discharge. As the inclination increases from 60 degree to 30 degree, means that as the length of the weir increases, so the coefficient of discharge increases. But as the angle from 30 degree we went to towards 60 degree, so the coefficient of discharge decreases. So the conclusion of this paper characterizes the study for flow features of oblique circular crested weir. The outcome displays that the angle of inclination for oblique circular crested weir affects the value of coefficient of discharge. So more is the inclination with the channel wall, so more will be the coefficient of discharge. As for 30-degree angle, the coefficient of discharge is 1.74, while for 60-degree angle, the coefficient of discharge is 1.24. Also, the research displays that the coefficient of discharge is significantly influenced by the upstream head over the crest ratio. Further, from the results, it is concluded that the coefficient of discharge is influenced by the geometrical parameters like radius and crest height of the circular crested weir. It was also noted as the radius of the circular crest increases, the coefficient of discharge decreases. With this, as the height increases, the coefficient of discharge decreases. These are the notations, and these are the reference which from which the data have been collected, previous data. Thank you for listening.
Thank you very much, Sohail, Jameel.